Okay, I see what happened. Didn't realize that I needed this time. I need to click start streaming YouTube because it was telling me people are waiting. Like, are they? Um, Look, I don't know. I don't even know what is going on. I hope the intro is not lost, but maybe that's the case. You have two QR codes at the bottom. One is my signal if you want to drop me a private message by text, in which case I won't mention your name unless you ask me to, or a voice note, in which case I will play it on the stream, so your voice will be heard. So I'm not doing the Google Meets today because I can't work the number of tabs. And I was doing so this would be then at, I don't know what time it is on this. I mean, I just have no clue whether I'm doing this right or not. I think I'm streaming. Oh yeah, 0:41. That's now I'm looking for this clock. Okay, cool. So at 0:43, change of plan. Yeah, I'd been speaking for like streaming. I thought I was streaming for like 6 minutes before I realized I wasn't. I'm doing the finite state machine because things. So we're in section A, and there is one in the 2021 section P1 SecA. Right. Which can close this, and I've got my CSV for the little, it's not even trace table, it's a states transition table. So we're not, tracing like a run through the machine. It's more like what combination of current state and input will lead to what new state. So this is one row per transition. So the current state is bound to be more than one. So for instance, S0, right? If the input is A, the new state is S1. Think I have, this was yours was the, so geographical term is asking, sorry, because I realized there's a delay, so I'm replying to questions without reading them. What was your question about? Was it the email about the, because you're doing Java and you fed rabbit and foxes to ChatGPT to see what it was saying, and they were like, oh, AQA loves string methods. It's like, sure. Yeah, I feel like this is not, I didn't kind of like read the whole output of the chat because I don't really like that. But I do think that generally kind of using, using past skeleton code is appropriate to figure out like the scope of the difficulty, because this one is a simulation, but you've got stuff in between 2017 and now where it's games and there's a lot of OOP, so having some encapsulation, some inheritance, like you're solving some of the same problems. So I would have like a look at all of the past papers. You don't have to even know the code to look at, oh, this is creating a new class and this kind of inherits this, and oh, look at the section C questions. Like any and all looking at past paper is, I think, good practice. The only problem is the skeleton code changes every year, so we can't really practice on. Well, you're learning stuff about the type of the question if you're doing mocks on using the actual AQA questions, because that gives you an idea of how they are. How they are specified, right? And then so there could be more than one row for each state. That is the point, but it should be a unique, only one row per combination of state and input, right? Because this is really more like, it's kind of like a truth table where like the first two columns are the input and like what is the output. This is the things that go into the logic, and this is the thing that come out. So from S0, if we get an input B, we go to S2. From S1, and then you just kind of like list them like this. From S1, you get an A, you go to S3. From S1, you get, no, you don't. So, sorry, A is S4. S1, you get, if you take a B, you go to S3. No, B, S3, S. So I'm going to do them breadth first. So I discovered this state here, so I'm going to pick it up here. S2, if you get an A, you go to 5. And S2, if you get B, no, wait, what? S2A is 5, S2B is 4. So that's going to be 5. Then S3, well, let's come in the order of the numbering. If you get an A, you get back to S1. If you get a B from S3, you get to S4. That looks like a very kind of a sink, right? If you're in that state, you cannot leave that state. So tracing a finite state machine is a bit of a tricky question, right? Because like this, the machine is like all of the states it can have. Tracing is when states change. So here, this is the state transition table, which is like a table thing. You know, sometimes if you see people on that year will have known there was this table in their electronic answer document. They're like, oh, that's a trace. Well, sometimes the table is an FSM, but it's kind of, you know, it's about state at different points in time, except here it's kind of output state based on current plus input. We still need to do 5 and 6. Well, actually, S4. Let's put S4 as well. No, let's do S4 here because it's in order. S4 is a sync, so that if you reach it, even with A, you get back to S4, or it's kind of an end state, and with B, you also get back to S4. Then S5, if you get A, you get to go to S4, and if there's no H6, yeah, I don't think. And from S5, if you get A. Oh, sorry, the diagram that involves state S2, right, okay, so you might remember my bon mot, which was RTFQ is equal to TFA over 2. Read the question, it is half the answer. So that's that. Anyway, that's cool, so I don't really need any of this. Yeah, that sounds more like it, right? S2 is these. Current state is S2, no, involving, that involves state S2. So you're going to have to list, and then another thing that lends you in S2 is S5. If you get a B from S5, you end up in S2. And those are your 4, 1, 2, 3, 4 rows. There's 2 marks. We can have a look how this is schemed. Well, let's finish the whole question right before we start on this, because that way that's not going to spoil it. Regular expressions can be used to recognize the same strings of FSMs without output. I'll take your word on this. Okay, right, so yes, so I forgot about that. So an FSM will accept, I'll do it here, right? This is the idea that the state of the machine will change as you pass a string. So all of those inputs are kind of read from a string. Yeah, this is tricky as. So the point is this will accept any number of A's or any number of B's in any combination. Wait, what does that mean? I mean, like does that mean like this end? Or if this means something, this might affect the regular expression. So if it's that regex, that's like, you know, any A and then any B in any combination, and it can start on anything, I would say it's A, any of them, plus B, any of them, and then A. I don't know, I need to kind of have some, because like I want at least one A or one B, so there's like at least one A or B, and then any combination of A, and then any combination of B, no, and then A or B, right, sorry, it's like, it's A or B in any combination, no, because that's not gonna do, oh, god damn it, no, this is gonna work, so it's A or B, at least one of them in any combination. I'm calling A B plus, but like I'm not sure what this means here. I think, is this to say this starts, because starts is S0 surely. Anyway, well, let's look at the mark scheme. I'm not super confident about my own answers here. S2 is the accept state. Well, accept as in, yeah, I'm not as hot on this. Yeah, that rings a bell, the accept state. But does that mean that we start parsing the string here, or like it's just that it kind of disregards the first element? What's it even that, you know, does this affect the regular expression is really the question. So this was 2021, right? Mark scheme. Oh yes, because I'm in the section B1. Let's put that back in here. Control B and Control minus. Put that back here. Okay. That's the QP. That's the MS. Yes, let's do that now. Ignore order of rows. A or B any number of time, or B or AB any number of time. Well, yeah, you can't just do I'm not sure why this one will not. Okay, there was not square brackets, then it was round brackets. Oh no, because this is round brackets, so that's like BA. Could I just define a class of... I feel like this is kind of equivalent. I'm not sharing my whole screen on my browser, so I can't go to like is it regex.com where you can where you can kind of like try regular expressions of thing, but like this will accept, yeah, A and B at least one. If answer is not completely correct over when we read two star meta characters and a pipe, or we should have a B and AB. We reject it without the brackets. Accept this with this, but not with that. I don't understand why I just couldn't get away with like it's the single digit A or B. Did I close it? The single, sorry, character A or B once or more, and that like, I mean, not all regex standard are the same, but surely that's, maybe it's like that. Fine, okay, so I didn't get the regex right, but that's the, I don't know if we get more on the FMS. I don't have like the exam builder of, I wish I could, back when I was teaching AQA, our department had access to like the thing where you can select your exam question from past paper, and this was absolutely brilliant. Oh, hello. No, this is, we don't want that. This is boring. Isn't that the one we did? No, hello. Oh, this is a this is a recursive trace table. I'm guessing, let's do this now. That sounds pretty good. I'll take it. So at 11:51, recursive trace. I don't... Sorry, there is a question from John Smith 12, which is, I know predictions are mostly useless, but I heard people say it is not likely at all for the table for Q1.2 to be a Turing machine. Is this true? I can't really answer that, but there's two... I'd be curious to see why these people are saying it's not likely at all, because there's two reasons why it could not be likely at all. The first one is like, there was literally a Turing machine last year, which I'm not sure is the case or not. And the second one is like, Turing machine traces have typically a much, I suppose maybe a much smaller number of columns or a much larger number of columns. I don't know, it's quite wide. Like the EAD is, this year is this, and that. I mean, you could have like, that's kind of like 6, 7, that's 7 memory slots and maybe an output or thing. So that could be like the 7 bits of the tape. I don't know. I think the conclusion is predictions are mostly useless. And if this information were true, what would that help you with? I guess like not revise the Turing machine. All right. So at instead 13:15, let's have a look at the recursive trace. That says 2020. I had it open a second ago. 2022 section. Oops. 2022 section A. Save my fsm.csv. Right, we are. Oh, it's because I went to the whole bottom because I was trying to change tabs and I completely butchered. Hello, yeah. Oh yes, I love this one. I love this. This is, I would set this to my like year 7 or whatever younger years, sometimes 10, because just to say that there's more to computer science than computers. Because like can you imagine if your A level opens with this question? It's basically a riddle. Right. 04. Why are we on 04? That's 03 one. 04. Dijkstra. 04. Yeah. All right. So do we want the full Dijkstra question or just the recursive? I mean, I might kind of warm up with the, I might warm up with the, recursive TG 2022.txt, I guess. No, you know what? I'm gonna do it in, I think, I mean, I don't know if VS Code can render them straight in the box, but if I can do an MD, I can kind of do a table like in the middle. Right, from the top, no, from this top. For each of the statement, complete any row to indicate what's next, right? I mean, okay, 4.1, true, false, true, false. If your graph is unweighted, so directed and undirected graph, it just means like, you know, you may have something coming into, that means you can't go out that way, right? You only follow the ones that are allowed with the direction. Could be a Turing machine, could be dice star. There was a dice star in 22, evidently. I wonder if there was one in 23. We'll have a quick look of the section A over the ages. So, and then can use the halting problem cannot be solved. No, this is, or is it? No, that's something else. Like Cantor's diagonal argument. There's a whole bunch of maths problems that are effectively homeomorphic, isomorphic, like basically mathematically equivalent to the halting problem. All of the ones to do with self-reference. I think like the Bertrand Russell, the set of all the sets that don't contain themselves type paradoxes to do with self-reference, because it's, you know, can you write a program to read the program to figure out whether it's going to stop in finite time without running the program, and then you can't, obviously. Yeah, suppose unweighted graph with one everywhere, I would consider, yeah, but then that's a weighted graph with one everywhere. I could suppose, yeah, it depends how you define it. But then it's sort of self-evident that shortest path are shortest in number of nodes. I don't know. Yeah, that's actually a good point. False. Or is it? Right, copy the contents, so we done this. Subroutine pseudocode, so GP, so that's probably a... Subroutine makes use of an array visited and an array connected node that stores a graph. V and P are presumed to be numbers here. You set visited as V as true, and then for each n connected nodes at V, oh, so that's the, yeah, that's the adjacency list, and V presumably is the node number. If we haven't n, oh, okay, no, for each of the n's we, oh Christ, for each of the neighbors, n for neighbors, right, if the neighbors has not been visited, then if, then this is where you call it, that's recursive, right, then you can recursively call it, and that will return true or false, I don't know that, then we return true, so this is kind of, we bubble up. If n is different than p is like the target, presumably, then return true, and 4 return false. Ooh, this is spicy. Okay, so we are at a node that we are visiting, V, and we have presumably a destination, a target, a arrival, a finish, right, with a PH. We get start and finish. I don't know what, P is definitely a node ID, but let's go. So we have visited V, so we set it to V, and then for each of the connected nodes, the n neighbors of the visiting the node we're currently visiting, if they're not visited, we call it again, and then if it is true, we return true. If it's not true, we are going to return false here as well. So you could just have like, return GNV, which is probably more elegant recursion-wise, but this showcase a bit better what's up. Now the base cases, which is like, you know, when you've hit the bottom and you're not kind of recursing, calling yourself. Yeah, a recursive subroutine is subroutine that calls itself. And our base cases are, so for each of the n, we are inside the loop. And this is the else of visited. So if we have visited this neighbor already, we return true. And it's not the target, we return true. And if it is P, don't know what P is, we return false. This is the same one. Yeah, this is the same one. Yeah, they just repeat it. Thank you. Yeah, because it's you have to flick over the pages. Oh, that's a new one. A subroutine. Okay, so we've got for function f doesn't take nothing for count from 0 to the length of visited minus 1. If visited at array count is not visited and return false. So this is have we visited all of the nodes, right? This is kind of a return false the moment we find. Sorry. Yeah, this function is have we visited all the nodes, because we will return false the moment we find a node that has not been visited, and if we manage to complete all of this without returning early, we then return true. E makes use of G. Okay, so function E will set all. Is that what it does? Is that what is this? That's not pseudocode. I mean, that is very high level pseudocode. Let's assume that, okay, so let's assume that, we've got something else that sets all of the elements visited to false. And then if G0 minus 1 is true, then return false, otherwise we return F. Bloody hell. So if starting from node 0, do I have a, yeah, all right, that's a test. I have a test graph to show it. All right, this is recursively checking whether the graph is simply connected or connected. Because remember, this is a graph. Like, because not all of the nodes of the graph need to be connected to each other. In fact, any subset of this, so if I just frame this, like just one node is a graph, a whole bunch of like loose nodes that are not connected at all is a graph. Like 3 completely different graphs together, they're not connected to each other, but they're independent, is a graph, right? So like a graph is nodes and arcs, but it doesn't have to be fully connected. And that's the important thing. So the point here is that I don't know why, I still don't really grok, not using, this term predates Elon Musk's horrible AI chatbot. I don't fully grasp what the P here is in G. So we start with minus 1, which is not a node number as far as I can make out. Do we set P to anything here? P, no. But we call it on V. Sorry. So this is going to call the neighbor, going to call G, no, mysterious function G, visiting the neighbor n with kind of iterating over, as we do for each of the neighbors of the current node V, and trying to P and passing the current node as P. This is a shitty one, because especially it doesn't look like there's a lot of marks. Well, I mean, at least they build you to it. It's like we don't have to understand everything. It hopefully should become clear as they. So let's have a markdown table count. V returned. So the subroutine F when is applied to the graph shown in figure 6. So F is I mean what Oh, right, we've called G01 and visited is true, false, true. So if we get like, we started saying like find all of the nodes connected. This is kind of visit all of the nodes connected. When you call it with minus 1, it's visit all of the nodes connected to G. Why do you have to, what the recursive call then like uses the current visited node, visiting node, the node being visited as the second argument of the recursive call, I'm not super sure. But the point is, when we started on 0, right, we found that 2 is connected. 0 is, we visited 0, visited 2, but we haven't visited 1. So the result of subroutine count is, okay, so count will start at 0, and then value returned. Sorry, F is here. And if that's false, it's not false, so we don't return anything. Right, and then we have, I suppose, 1, which is false, so we return false. Because they've not, question 4 continues on the next page. The gift that keeps on giving, slightly spicier graph, I love this. Okay, 4 nodes, that's the content of the array connected node. So 0 is a neighbor to all of them. 1 is 0 and 3, 2 is 0, and so on. Is this like this still the same one? Fine. Okay, I'm in Obsidian. I can like do tables just like that. 0, 1, 2, 3, 0. 0, 1, 2, 3. I think I got that right. Yeah. And then 1, 2, 3. So we don't even need the middle, right? The middle diagonal is every node is connected to itself. An adjacency matrix. I mean, I would kind of like, okay, they have blacked out those squares, which is fair enough, but I mean, debatedly, complete as an adjacency matrix. So they will accept ticks, they will accept true, they will accept 1, whatever. So you could like put, you know, so I'm going to put 1. 0 is connected to all of them. So 0 is connected to all of them. So 1, let's make that, you know, it's going to be neater. I don't know if Obsidian will parse this correctly, but at least it's actually visible on ASCII because we're only dealing with like 1 character each. So clearly I did 1 column too many by the looks of it. No, I didn't. 0, 1, 2, 3. Or did I? 0, 1, 2. Oh no, this is wrong. Okay, back on track, back on track. 1 is only connected to 2 and 3, so 1 is connected, well, 1 is connected to 1, and then also 1 is connected to 2 and 3. 2 is connected to itself and 0, which we've already captured here, which would be in the mirror. That's kind of like the mirror equivalent is here. We've captured here. The mirrored by the main diagonal is here, so this would have been here. So it's not connected to, well, it is connected to 1 because they all are, but it's not connected to 3. And then 3 is already connected to 0, we captured that, and 3 is only connected to itself because at the bottom of the table there's nothing to... It's just like a lot of... it is a highly connected graph in that there's only 2... Oh, that's not right. 3 and 2 is 0. And there's another one that's 0. It's 2 and 1. 1 is not connected to 2. Sorry, that's the other one. Right, so like this would have been, if all of them were connected to all of each, every node was connected to each other, that would be all 1s in that adjacency matrix. But because you know you have 2, you know, arcs that are missing from this, you know, there's like there's 2 zeros in this table. If you don't count, this is the 0 that indicates the node 0, right? Like this, but there's 2 zeros that indicate or falses in the table, and those are here. Right, another, are we doing this again? Yeah, of course, this is still figure 3. Oh, hello, this is more my speed. Right, fine, okay, super. Well, I mean, in tracing it, I believe we will understand it. So, call, sub call, v, p, you know, I'm just going to call them like 0. We know it's in visited, right? Thankfully, we don't keep too many. The graph shown in figure 7 obviously is the slightly more complex one. And I forgot a number here. 1, 2, 3, and n. Sure, and this. Okay, the first subcall is... Sorry, this starts at, you know, this starts with false, false. Okay, slightly regretting this now, but false, 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 nothing. First subcall, G 0 -1. Pipe. So V is 0, that's the first thing we've called it with, and P is -1. Okay, this is where this is going to break a little bit. Okay, and what happens there? Visited V equal true, so we're putting true here. Let's make that a bit nicer. That's not well, okay, and then that doesn't, we don't change any of this. You are allowed to only populate trace table when values change. Raoul Sherpa V70, if you don't think that is right, you need to tell me what you're referring to, because there's some lag between, first you're seeing the video and my producing it, or vice versa, and then my actually seeing the message and the thing you've seen on the screen. Okay, we have set it to visited, and if visited isn't false, then we get for each of the n in connected nodes. So the connected nodes of V are 1, 2, and 3. So we're going to, if we've not visited one, that's false. So we are calling GNV. So that's the next recursive call. So n in that instance, it was 1. And V, so V that we use for P, right? Kind of in the second argument we pass V, that's 0. This will make this is a call, a stack frame, a call frame, right? In the call stack. So as you call function, there's like, what did I call and what are my local variables? The local variables in that instance, so that's 1 and 0. This doesn't change from one call to the next. It's a persistent data structure that everything can be written. Any level of call of whatever flavor of this instantiation, I suppose, of this function can I've got access, read and write access to this little array. I've spilled some water on me. Very good. And that's still false, and when it doesn't change, we don't need to change it. Why is this not? Okay, I see what's happened. So the first n we call is 1, right? Because like we're in the for each and we're still at that level. And when on this, the first n we're going to call here, because this is going to do a depth first search, because the moment you find something, you first like get through its neighbors one by one. So we've called this, we've set visited 1 to true, and then for each of the, right, we're in the second call, the call from 1, and then for each of the n of the connected node is 0 and 3. So we're still in the same call. First, this will take the value 0, right? If we kind of do it, I mean, it doesn't matter, right? Like they'll understand that you have, right? When a value changes, you can put in a different line. We'll understand, because if you do a line where nothing else changes, it's as if it was in the same one. So the first thing we're going to call is the first neighbor, because we're iterating over all the neighbors of node 1. That first neighbor is 0. But as luck would have, visited n is true. So we are getting this, and n is different than p is not true. This is where I messed up, because there's an n4, so if we fell bang the bottom, we don't return false straight away, we go to the next one, obviously. So this one doesn't do anything, and then the next one we visit is 3. And this one hasn't been visited, so this calls 3, 1. And the circle starts again, or V this time is 3, or P is 1. This hasn't changed at all, but because we're visiting, I can't do spaces, I need to put the delimiter in the right place. Because now we have visited 3, we put a true in this, and the first neighbor we have is, first we get 0, I mean you can do them here, right, 0 first, and then and then a 1. And then that's finished. So G3 has found all of the neighbors, which means it's going to return false. Which means it's going to return false, which means in here, as we were testing 3, that did not return true, which means we go to the next one. So we are back to this is the idea here, is that, you're back to that level of calling. So you're continuing the loop where you were. So again, it's G1 and 0, this time running it again. We're back to V. This is why they kind of specify it here, being 1 and 0, obviously. This hasn't changed at all. We're just going through the next neighbor. So we've done 1, 0, we've done 3, and that, no, wait, what? Yeah, sorry, 0, 3, that finishes. Does that finish? 0 was visited, and then 3 wasn't visited, and we explored one of them was visited and the other whatever, and that, or both of them were visited, and that, so that doesn't return true. So we fall off, we return false, meaning that we go to the next one at this level. So this is going to be G2, because the second neighbor that was returned by, remember like way back, the first time, the first flavor of it we called was this. Okay, and we are back to G. G0, 0, -1. Soviet man 0964 is saying, oh God, it's been a long time since you've popped up in my recommended. I recommend your video, were really useful for my exam last year. This is thanks to the magic of the algorithm. Sometimes you got to trust the system. I do get you know, a lot of, I don't know how I can reframe the, I'm also streaming on the shorts feed apparently, because why not? But of course they're seeing literally the middle of my, the middle of my Visual Studio editor in between the window split, but at least they know it's live, and we're talking about AQA paper 1, section A in that instance. So we're back to this recursive call, where V, if you'll recall, felt like forever ago, was 0 and P was -1. So what does that tell us? The next neighbor, we've done 1, right? And so like this hasn't, this is still true, true, false. True, but this time we are with the neighbor number 2, and this hasn't been visited, so we go into it. G2, 0 is calling G with 2 for V and 0 for the mysterious P, and this time this will flick everything, so now they're all visited. Not that it helps us much. Hasn't changed, and this will take the value 0, find that it has been visited, and is there an output? Okay, I'm blanking here. Final value return. So where this is about the return, yeah, that'd be good to know what it returns. So we call G2 with 0. We're gonna find that it's been visited. So we go into the else and N. What's the neighbor? 0 is different than P, so we don't return true. So I think we're gonna return false. But I a predicate, sorry, 4.6, a predicate, that's a function that returns a bool. As to whether, it's funny because I'm just kind of like, whether allows me kind of to flip it once I don't know, whether the graph is connected, fully connected. No, that can't be that. As to whether the graph is a tree. I got a good hunch about this, because this one, if it's true, then return false, and if it's... I hadn't noticed the broader function E, because this is what we're tracing. Then they ask us to trace F. So they're telling us about E. They've told us, okay, they introduce with G, what's a recursive subroutine, yada yada, and then they tell us about F, which is this weird thing saying, that's quite clear. It's like, have we visited all of them? Then E uses both of them, so either G has returned true, which, yeah, I don't, I'm getting like graph vibes. And then in F, then they only ask us to trace F. So like, where does E come up? Right? E, they're telling us about an E that uses both F and G, and like at no point is actually used. Okay, so I'm much more confident that the type of graph, it's depth first traversal. Right? Because we kind of immediately get all of the neighbors and start looking at the neighbors before we look, try and kind of analyze or call the function onto the immediate, not the neighbors, but like the sort of sibling nodes of that, the neighbors of the previous one. If it is undirected, what can I determine about the graph when the value of true is returned by? So between E. Isn't that the same thing? This feels like the same question as this one. I feel like the direction. I felt quite frustrated. Usually I'm pretty good at like A-level question, particularly those, this kind of data structures, graphs and trees and stuff. This one is stumping me quite annoyingly. Fine, I will look at the mark scheme and figure it out in shame. Oh, we're in the right place. Right, so things are not connected with themselves, are they, by default? True, okay, so getting back to John Smith 12, it's true, false, right? Kind of, your question is like, yeah, but then in that case, you'd make it explicit with values of 1, and that will give you the power to kind of have values of more than 1. A subroutine calls itself, 0, 1, false, fair enough. Okay, so I consider that everything was connected to itself, but maybe that's a bit daft. Actually, if everything was connected to itself, you'd see like an arrow saying I can get like from myself to myself. This, I guess, matters depending on what you're modeling with the graph, right? It doesn't really make sense from a physical location, but when it's a state graph, like we've just seen in the previous years, tricky trace FSM with a regex thing. Okay, 0, 1, 1, 0, 1, 0, true, true. Then this one gets set true, 0, 3, 3, 1, G, 1, 0. What's the point of n though? I mean, surely they've told us, like, what, you've put an n in there. I mean, at some point they're gonna, what? Okay, what did I get wrong here? So I got correct up until here, and then I backtrack to this with 3, 1. We set it to true, we go to 0. Why are we not? Oh, no. We go to 0. Ah. Okay, 22 QP. Free one. Sorry, we were. Yeah. So we're in the for each of the connected, and we go to 0, and then visited is false. We don't call it. And so we else if n different than p. Yeah, so at this stage we don't go there when we return true. I messed this one up, right? Because like we've managed to get n different than p, which is we've already visited 0, but it's not the immediate. So we've already we've already visited 0. Yes, fair enough. We have already visited 0 in that instance, right? But it's not our immediate predecessor. We didn't come from 0, and we managed to already have visited it. And that tells us that if we were able to visit, there's a neighbor I can get to from one node, and there's a neighbor I can get to that I have already visited, but it's not the previous one. So the previous one is here, and the previous one was really connected to the one we visited because we've just proceeded by connection, which means that you've got, I've given you the minimum case, which is a triangle. There's a cycle in the graph. That's the correct answer. So, which was like here, as to whether, Would that feels like redundant with... so if it returns false, if it returns true, that's the same thing. Like there's a cycle in the tree for it. I'm kind of writing it to go. Yeah, no, I figured that before reading the actual answer. Yeah, because I missed this one. So this is, I should have checked that much more assiduously. So going back to the trace table, we were here, right? We have 0 and we have visited 0. So we go to this else, but 0 is not equal to the v we called it with, right? Because n, the 0 is not equal to f. So we're going to return true. We return true to this bit. We kind of like pop out the frame, meaning that we'll return true from that bit, right? So we just immediately kind of popping out. The previous one was 1 0, the call stack. We're still like all of those things are, you know, it's kind of like, I guess you're here, but like you're not iterating over the next one, because again you get a true that needs to bubble up. You've hit the base case. Oops. One of the base cases of true, which get to bubble up all the way to, sorry, this was G1 with 3, yeah, and then there's G0, no, then there's this one with 1, right, which is the one that returned true, and then we're here, and then that's true, sorry, yeah, yeah, I should have, you know, would I have seen this in exam condition? I mean, I'm taking a long time. I don't know, a long time. How many marks total are there? Like 6, 7, 8, 9, plus the ones before, 10, 11, 12, 13, 14, 15. I don't know what time I started. Yeah, I kind of started. Yeah, I started at 13. That took twice as long explaining it to myself, but yeah. So what does that tell us? Control page. Right, so yeah, you notice that the trace table, that's interesting, right? Kind of like starting here, that we started to write, visiting for true, not changing it, that's 1. Visit 1, descend to true, and then visited 3, set to true, so that's 1 mark if you get both right. There's 1 mark for this column. This is marked a little bit differently. There's 1 mark for all of these, because you're most likely to get these right first, and then if you mess up, so when I messed it up and misunderstood it, I would still be getting 1, 2, 3, 4. Well, yes and no, right? Like maybe 1, 2, 3, which I'd be a bit gutted to have spent that long on this for only 3 marks. What can I say, right? Like, it is difficult. It's not meant to be a walk in the park. That's why they call it the A level, not the Z level. I also don't know if it works. Okay, determines the graph contains cycle or not. Yes, step things first, the graph is a tree. If it's true though, the question was like, what doesn't a return of true? Okay, we're all in agreement here. I mean, I'm kind of like, this is 2022 as well. This is a real question paper that was set to actual students, and this feels like this is okay, it's 1 mark admittedly, but there's a slight Boolean mistake here. They've given us an example with an actual cycle, right? So it can't be a tree, and that returned, and I'm not looking just at my dumb work here, I'm looking at their like trace, right? Like we have a cycle, it returns true, and then they're telling us, well, if it returns true, the graph is a tree. It's the opposite, is literally opposite of what a tree is. So that's the problem you're facing, right? You don't know how accurate your marking is. Now this is kind of called in between the noise anyway, because like 1 mark, but like the fact that it's broken on the thing and I'm not seeing, I mean, those are the, that doesn't look like a full, I know, because in AQA put the mark scheme in a different, because normally you get examiners remarks, which is after they've marked like enough of them, they're like, oh, the students like didn't really do very well at this because we asked the wrong question, or like we put the wrong mark scheme. Maybe that got updated when they noticed the mistake in the original mark scheme. Hopefully they kind of, yeah. Q Texas, I'm just wondering, how do you feel? Who says I hate AQA trace tables? They are so bad. I'm wondering what is the difference between AQA trace tables and other trace tables? What's specific about AQA ones? Did you have a different board at GCSE that was kinda? Because I think trace tables are trace tables and they're a bit of a stinker. What's annoying really about the recursive ones is that you can't presume that every row below is, you know, replicates the state. If you're in a nice non-recursive algorithm, every row underneath, what am I looking at here? Right, is there a trace? Was there a yeah, there was the trace in 23 or 24 that I was doing yesterday, which right. Okay, the way that's marked here, you see, like, there's one mark for the first row, there's a second mark for that's more of a non-recursive trace. Oh yeah, that's, thank you. Ed is saying, see, read the FQ. It's been pointed out to me in the chat that I'm moaning about this. Well, this isn't correct, and I was also moaning that, oh well, E is a massive distractor. Like, what's the point of E? Because we've never tested E, and actually E is fully connected, right? Meaning that a pass of this. So that's the first thing that tells us, because if we run F after we have run G, this tells us whether we visited all of the things or not. Oh, sorry, it sets all of the elements to false. Sorry, it sets all the elements to false. Then it runs G. If that's true, then there's a cycle and there's false. But if there's no cycle, if there is no cycle, we should, because the thing will just abort, because it hits on the base case the moment it finds a cycle, because it finds something in its neighbors. At the current node, finds some neighbors that have already been visited, meaning there's an other route to that neighbor that's already been visited, that from the node you are here now, and from wherever you visited in the past. So if that's not returning true, right? Like, we didn't find a cycle. So when we find a cycle, we bail out. If we didn't find a cycle, we need to explore the whole tree, because we know there's no cycle, so it's a tree. Well, assuming it's undirected, of course. We have to visit, like, for G to return a false, we have to visit all of the nodes that are connected to the starting node, we call it win, like the first argument of this. So if after our f function that checks visited, after we've called G, will contain all of the ones that are connected, because we visit all of the connected ones, connected to the starting node. And so if all of them have been visited, that is true, otherwise we return false. And those two combination, right, it is fully connected, and it has no cycle, and if you add this, these are the ones that are done by the algorithm. Thank you so much for Ed 2006 for pointing out that this is about subroutine E, which I was like, why is no one asking about subroutine E? Yes, in addition to this, if it's undirected, which is your next criteria, then bang on, it's a tree. Right, whew. That was 2022 QP and MS. That's 24. That's the recursive 22 trace table MD. Control W my word of that. What's up? Turing Machine. Well, let's find one. So 23? No. Oh, I love this one as well. Yeah, we start the section with a riddle. No, we've done this. Have we not done this? Oh, no. Hello. So this could be, right, there was, look at this, 1, 2, 3, 4, 5, 6. Haha. And we're in section A. This could totally be a blank, sorry, this. You'll notice that in here, right, they're like, copy the contents of the unshaded cell table into the table on your electronic answer document. Oh, right. You mean like this? Wait, that's slightly under my effect. Like this, right? So this could be, this question 4.2 this year in section A could very well be what's the missing yada. What's the missing bits in this algorithm? I'm not doing this. So where can I find it? Oh, hello, regular languages. That's also good. That's a good bit of section A. 23 has slightly different regex context-free languages. Yeah, this, am I on 23? Yeah, this is the one, right? Like context-free languages. Oh, hello. Yeah, I knew there was a, right, so it wasn't 23, there was a state machine. Yeah, right, no, hello, and there's some type. Oh, yes. Well, I mean, you know, current state, yeah, that looks like a, and same deal, that just like we've had this, this could very well be this, yeah, right? This could very well be the trace for a Turing machine. I can kind of believe that. Oh, yes, cool. I'm totally looking forward to doing this one. Okay, we are in 23, 23 Turing machine. Is it a Turing machine or just a regular machine? Any old machine, a Turing machine, Turing machine. Lean mean Turing machine. Yeah. And let's have this here. I love those because like they like to have fun, the examiners. I think my end game might be to design some of these or maybe write some skeleton code. That could be fun. Because you know, you put like the scariest graph that takes a whole page or like a whole, you know, what do you call, like, thankfully AQA have got their own like instruction set for the assembly or assembly style language, but OCR forces, I was going to say little man computer, OCRs like use little man computer, which I think is one of the many ways in which their specification is inferior. But you know, you put like a massive assembly thing, or like, and then it also comes with a recap of the instruction set, which by the way in OCR they have to remember what all of, there's fewer of them in LMC, but it feels a bit GCSE as I'm remembering. Oh, we got someone that's like not sitting the A level this year in the comments, and they're like, oh my god, this brings me back. Yeah. Okay, so this is the Turing machine. The current position is indicated by the star symbol, which is, yeah, here. So we are in 0, and there's like an H, and not panic. Okay, the label nothing 0 in transition from 6 to 7, 6, 7, everywhere it comes up, means the machine is in state S6 and a blank is read from the tape. The 0 should be written to the tape, and then the read write head is moved one cell to the right. That's fair enough, right? So like it's what is the state and then writing motion. Whereas here, oh no, there's more than this. If a machine is in state 3 and like you made any given state and then the read the write head. So you're not writing anything. You're just walking back. So yeah, let's just tracing the computation of the Turing machine for the first 20 steps only. I think I may do more than that, my friends. Okay. I am actually legit excited by this. This is yeah. And there's a hash in this one. 1, 2. Yeah, and there's 2 blanks. The hash, which is the start of the type. We start at 0, which is like the head is here. Which is going to be annoying because it means going to be one cell that's going to be slightly larger, so I'm going to make them all 2 characters, wide and then 0 space. I don't know where there's a hash. 1, 2, and then why is there a hash? Like, what does the hash mean again? Ah, okay. Part of the tape for a Turing machine. Sorry, hash is an actual symbol. The actual, I don't know, I don't like this. Like, normally the real Turing machine can only read zeros and ones, right? You can only read like a 2. That's basically a 2, right? Like, if you're able to put something on the tape that says, oh, this is not about the value, it's about like a special, you know, it's a special location, then you need more slots of the tape to write this. But yeah, whatever. This is a sort of enhanced Turing machine, a ternary Turing machine. You know, you do what are you trying to kind of teach like really mathsy concepts? Because that means it's kind of like, you know, the computability, the work of Alonzo Church of lambda calculus fame, who was Alan Turing's PhD supervisors in Princeton University, a small university on the east coast of America you may have heard about. Yeah, this is like really foundational mathematics for computer science that predate the first digital computers by about 10 years. So it's understandable that we present to you as, you know, A-level, sixth form students, a very simplified version, and there's a moment when it breaks down. So for the sake of argument, let's say we have a third thing and we need to count all of the 0. I can tell you it's going to return 3. Okay, so we've got this, we've got a blank one for some unknown reason, and then that's probably it, right? I'm kind of not going to do the dot dot dot, so say tapes continues, and then here I'm going to put the current state. And we start. Yeah, I can do. I'm not doing predictions. Yeah, there's some in like the previous streams which have index. So if you go back to, there was the stream on Saturday. The Sunday one, I've not put the chapters yet, but we've played the prediction game. There's also my good old list. I can do some on simulator. I'm just going to finish this because there was my stack of like stuff to do on section A. And maybe, yeah, we get time, it's only an hour in. But yeah, I will get to section D in a moment, but there's plenty of section D in my past streams, particularly if you want some predictions. Well, we know like the 5 is bound to be some input validation. You can roll your own, but like if you want to input validate get cell reference, that's a good one because you need to figure out how to pass the boundaries. I touched upon this on yesterday's stream, and which doesn't have the chapters yet, but I'll put it in so you can jump to it. The 8 and one of the 12, like one of the 12 is definitely creating a new class, so you can have a look at the zigzag tasks. Again, that's in the description of the previous 2 streams. The prioritization of the zigzag task, which I had. Oh man, where am I? I had yeah, I don't know where I've put them though. Is it tasks? No, I can't find it. Okay, I had they're in the can't find it. Yeah, well we'll get to it. Let's just let me do this because I want to have some fun. All right, so this is fun. Current state was at 0. We start there, and then the receiving state is the end, is it? I don't really understand what's going on there, but that doesn't sound. This feels like I should kind of figure out what this special meaning is. Right, so we start in S0 and we are here. What do we read first? A 0. So we find the arrow 0. It's like write nothing and move to the right. So it's going to be very simple. And then we, oh my god, I'm going to have like, it's going to be a bit newer. Going to get a hold of the blank. So we write nothing. I'll put a X for nothing space. And we move to the right, which means that we now are reading this 0. So I think it's like erases all of the... Okay, we move to the right. We now land in S2. So S2, we read a 0 again. Is it this? No. Okay, we 0 and we move left. Oh, I remember, you know, this is 2023, right? Yeah, I remember my level students like moaning about this one. It's just a crazy one. So this was the start, and so we get X, and we, so we, 0, we don't write anything, we move back to the left. So we've got, shoot. And that we've not touched this, and so we still have the 0 and the hash, like the other delimiter in here, and so we move back to the left, we move the head, and we are now in S1. Nice curveball, where we're reading a hash, which means I guess we write nothing and move to the left again. That's why we get those extra bits. Right, the head is here. No, sorry. No. S, sorry. We read nothing, we move back to the right. Hash and blank is different. I indicate blank by X, because for me blank means, in a trace table, blanks means blank means the row above. And so yeah, I wanted to say like the problem with recursive trace tables, in non-recursive iterative trace table, the state of any given row is of course literally just based on the state of the row above, because the memory doesn't change. and then, you know, maybe one or two variables have changed. Whether you want just to do like one new row per state change, whatever, each variable, or just kind of like, as long as you encounter them in the order of the table, write them all in one row, doesn't really matter. But when you're in a recursive mode, because you're popping back the call stack, you can actually return to a state where like you have to reload all of the state of, not in that in our instance just a minute ago or maybe 20 minutes ago, not the array of visited, that was the crucial kind of state holding part, but in a really purely stateless functional program, which I believe is on the spec. I think, is that in A? Yeah, it's always a little bit of functional every year. Well, not every year, actually, I'm lying. But it's testing like so basic. As long as you know your maps and your currying and your map and fold. Yeah, this is just this kind of light smattering of fun functional. You don't have to kind of speak Haskell fluently. Okay, so where was I? I've lost my place. I was in S1 and I have encountered a big nothing that I wrote in S0. So I'm moving back to the right. Okay, that's super helpful. Thank you. Why? So now I'm back here, I move back to the right, and then, yeah, again, this is 0, and the end of what we want to, and I move back to the right, and I stay in S1, actually, yeah, so that's cool, that's done. And now here, I'm in S1, I encounter I'm reading a 0, so I write a blank and I move right. So it basically has to go back as much until you reach the end, and yeah, that's interesting. Okay, so let's, nothing. I should really have this in my paste. We write a blank. So it's this one, right? Kind of like this one. 0 from S1, write a blank, move to the right, blank it, move to the right, meaning the head is now here, and move change state back to S2. Are we writing some ones at any point in this hellscape? Oh my god, yeah, I'm worrying about how long this is going to be. Okay, so we are now in S2 and our head is on a 0, so what do? We move to the right again? Did we not? I messed up. Sorry, S0. Yeah, we were here. We read a 0. We wrote a blank. We ended up in S2. And then when I read another 0, I moved to the right. I don't know where I moved to the left. Yeah, I messed this one up, right? So I was kind of here. I moved to the right. But go to S1 though, right? So that remains correct. In S1, in this one, I read a 0, so I write a nothing and move to the right, which is fine. So I'm guessing, and I'm back in S2. So actually, I'm kind of like back here. Yeah, I don't know why I was... No, wait. S0, yeah. 0, write nothing, move the head to the right, end up in S2, done. S2, you read a 0, write nothing, move the head to the right, you end up in S1. Yes. S1, I'm reading... No, you don't write nothing, you just... Shit. S0, yes, okay. We started in... Struggling a little bit. I'm just shortening CTST for current state, because that way I can then zoom back in. Right, okay, S0, I read a 0, I wipe it, move to the right, end up in S2. So that wipe it, move to the right, end up in S2. In S2, I read a 0, I don't wipe it, I move to the right, end up in S1, I'm here. In S1, I read a 0, I wipe it. So yeah, this is where I messed up. This stays here. I wipe it, I move to the right. wipe it, move to the right, end up in S2. In S2, I'm reading the hash, so I'm going back. That's the end character. And so that doesn't change. X, 0 space, X, wiped. Yeah, I can see why this would have frustrated my class of 2023. NGL. Sorry, what am I doing? Whoa. S2, right? And then I'm reading a hash. I'm gonna have to do nothing and move to the left. And do nothing and move to left, and that puts me in state 4. And from state 4, I am reading nothing. So I'm moving back to the left and staying at state 4. So this is going to be, oh my God. Do you know what? I think I might already have them in the clipboard. So 0, nothing, or 1, whatever, like in whatever state, as long as you don't encounter the hash, you gotta move back. So I'm moving the head back, and then this is an X without the star. This is a hash, that's the end. Some free cells just for fun, and we're staying S4, and we're going to keep on doing this until we reach the hash, the starting hash this time, because we're approaching it from the other side. So first we are encountering this, but we've read a 0, so that still leaves us in S4, and then we're doing that, but we've read, yeah, and now we're finally here. The head is in the right place. The heart's in the right place, and what's wrong here? Oh, who's excited about the SpaceX IPO? That could be the start of the crash of the bubble. The first 20 step only. Wait, well, oh, fine, okay, well, I'm only at step 9, so that's reassuring. I'm only halfway through. I'm glad I'm not in 2023. I would have probably left this one for the very end, right? Like all of the coding ones. You know, suddenly that 16 marker on, like, what was it, Dastan? No, what was this one? Yes, that was Dastan. Yeah, suddenly the 14 marks or 13 marks final on Dastan doesn't sound that bad compared to this horrible Turing machine. There's so many moving parts, right? Because the state of the Turing machine is not just the state, that's like one variable. There's the state, there's the full state of the tape, but also crucially there's like the head. So your movement, like you're moving the tape back, but you're moving in the state diagram to like another S. And like you see, I messed it up, and kind of you're off by one. It's really easy to mess up, and like it's really long as well, because you're literally breaking down everything to like, I'm just writing, reading until you. This can do quite powerful computing if you can finish the trace table, or if you can simulate it in software, I suppose. Right. So we are now here, and I have finally read a hash from S4, which means this leads me in S5. I mean, I don't know if I'm documenting the current state in the right place. Yes, because I finished, the current state is in S5. Let's put it at the end of, it's at the end of the line for a reason, right? Kind of like, you know, current, this was my starting point, whatever. And in S5, if I read 0 or 1, so oh, fuck me. No, sorry, I'm still in S4, because this is how I ended up here, right? Kind of like I started, like I've just moved ahead to this, and reading that nothing, right? Kind of move left. Oh, Christ. S2 here has read a hash. It moves back and ends up in S4. S4 reads a hash, moves back and ends up in nothing, sorry, moves left, ends up in F4. Reads 0, moves left, ends up in S4. Reads nothing, moves left, end up in S4, reads. From S4, I'm reading a hash, so I'm moving left again. This is why we have those spare ones on the side. And move left and end up in S5. Now I'm reading nothing, so, well, it's good that it knows to like a 0s and 1 will make me move all the way back, but that's not the case in which I am, and if I then write nothing, which there's already nothing there. No, sorry, if there's nothing, I write 1. Oh, you're going to write as many 1s as there are, like, zeros in the... I don't even understand. Yeah, I probably got it wrong somewhere. Yes, I agree, geographical term. Now that I've looked at this one, that sheer number of columns. But, you know, there could be a program based... Sorry, if you're not watching, I don't know if the live replay is on, it's probably on, but like, could it be, could that the Turing Machine trace table in, from the EED? Maybe. It's worth contemplating. I mean, the thing though, right? Well, hold on. Actually, it's only work 5. Because the positioning of the... like what's around that big trace table in the EAD is also important. Oh no, not like a third tab. We're not kind of completely, yeah. At least the people in the short stream can read the middle. This here, right? There's a 110, 1 mark, 1 mark. 1 mark could be worth 8 mark. I don't know. I mean, this was only worth 5 last time. Just the trace, right? But like this is within a broader you know, question where on this one there's another 2 marks, 2 marks, 1 mark. So that's a total of 9. Yeah, I suppose that oh, I'm not even... This is massively unfair. I'm sorry. I'm just kind of like really salty about that because it's like this is a really complicated question and they tell you had 40 minutes to do, you know, to do more than what you'd expect. So it's 5, 6, 7, 8, 9, 10, 9, 10, 14, 15, 16, 17, 19, 21, 21, 24, 26, 27, and then 32, 34, 36, 37. So it's like you don't have much room of maneuver for a mark a minute, and there's no way you can do this in 5 minutes. Completely unreasonable. Yeah, I feel for the 2023 cohort. Like, what was good to know is like, I mean, you know, 2 of them are at King's, one's in York. I mean, they did fine, is what I'm saying. I don't really care. They don't lose sleep over Turing machines. It's not; those are not the machines. It's not the Turing machine they lose them sleep over. Okay, I'm like getting losing the will to live here. I'm in S5, or I was in S. I'm entering S5, and because I've moved left from reading this, and I've written a 1. I moved left again. No, yeah, written 1. I moved left again and end up in S7. Yeah, this doesn't change. So I get a 1 and I move back here, and I am now in S7. Well, they say the first 20 still though, right? Kind of like that's like 15 seconds per row. Well, I guess that's feasible in 5 minutes, whatever. Yeah, I kind of messed this up, didn't I? This is meant to be blank, or it doesn't really make sense, but this is what's confusing me. Messed up the header in the first row. What's missing here? Yeah. Okay, so we've ended up in 7. We've written a 1 because we found nothing. We've written a 1 and we moved right back. And then in here, 7 reads a hash and it moves right. So I mean, most of the time I'm wasting here is like typing the bloody CSV, not CSV actually, markdown style table that I'm trying to kind of line up with the ASCII spaces and stuff like that. So yeah, maybe on paper it'd be quicker. So we are at S7 and we read like things. So our head is here where there's nothing, as we'll remember. And this The rest doesn't change, so I'm not writing it. And this ends up in S0. Oh no, we're all the way back. Okay, in S0, we're in familiar territory. If we encounter nothing in S0, we just move to the right and stay in S0. So we're gonna get all of this. We have moved to the right and we stay in S0. Then we reading a 0, so we write a nothing. Okay, that feels like we're doing the same thing. Let's say that, yeah, okay. So we blank it and move to the right and get to S2, to the move to the right, where there is also nothing currently. I hope, because if you mess this up early in the table, I'm surprised that there was like the 0 hanging, but like both sides were being eaten or kind of blanked. And this takes us to S2. And then I feel like I'm in more familiar territory here. S2 finds nothings and moves to the right. Christ. Really? S2 finds nothing and moves to the right where it's going to encounter and stays on the same state. So, do you know what? Actually, I never used this, but there's the insert. Yeah. No, well, not here, obviously, but ooh, what have I done? Oh. Yes, I was trying to say, so we're gonna, what, oh, mate. S0, we've encountered 0, which we wiped and moved to the right to get to S2, and then I encounter a nothing and I move to the right again and stay in S2. And this is where my insert thing is going to be helpful, because I can put a space here and a star here. Finding new and more useful way of doing that table. And stayed in S2. This time I'm reading a hash, so and it's going to move me back and put me to S4. Moves the head back. Go to S4. Then from S4, we basically move back until we reach the old, dot. I'm sorry, it's going to break the table. So annoying. Whoa. S4, we're still moving the head back. Eds 2006 -T5R says, are there any of the zigzag question you think could be similar to the ones that will be on the paper? It depends on what you mean by similar, because the AQA tasks are always much more narrowly specified. They break it down into subtasks, and you need to create this method, and with zigzag tries, but like they're much clearer. Like they left a lot of stuff open-ended. I think what I've done in the other streams, like yesterday and towards the whole end of Saturday, like the whole last half hour of Saturday, is as I'm chatting to the chat, I'm listing like what are the topics in the zigzag questions. And then I'm prioritizing it, not so much this. So I'm like, yeah, this one, we could have something that looks very much like this. So anything for a subclass for the 12s, anything with stats for the 8s and the 12s, and like your input validations for the 5. But what I'm doing is I've then prioritized the zigzag tasks to say, if you were short on time and starting to, wanted to make the most of the time you have until Wednesday, do them and redo them in that order, because it's not so much about like which are the ones that are similar to the ones that will be on the paper. What matters is which are the smallest set of zigzag tasks that make you practice the widest set of relevant bits of the code that them are likely to be on the paper. I don't know if that helps. Or suddenly cover you for whatever could show up on the paper. Slightly different, but nevertheless. Watch the one on the mark schemes for section B's and D's as well. This probably like I should reorder the playlist so it starts with like the mark schemes, 10 useful things, and then the classes walk through, which I might want to do again, but whatever. There's loads of, I'm giving enough time to this. It's a silly endeavor. Okay, so now I've got this. We're going to move all the way back, staying in S4, plodding along quite nicely in insert mode. Let's Okay, just make this one here, and then also. And now we read a hash, we move back, but we go to S5. So we move back to here and go to S5. This feels like, oh, the first 20. Oh, we've done 20. Okay, so just like, please make it stop. I want to kind of see that through to the end. Because I feel like this doesn't tell us how this could like even read the number. Is it meant to write the number of ones? I think like every time this is like it's meant to be every time it reads a 0, so it wipes finding 0 and blanking them, and then if it finds a 0, it has to move all the way back past the start and writes ones. And then when it finds the end, well, find the next one where it doesn't have a 1, write a 1 there, and go back to the next one that hasn't been read and blanked, finds the 0, and when it finds the 0, move all the way back to this. But like, I feel like we keep on moving until like the S2 doesn't write. Right, you've got writing state and non-writing state. Could I just highlight this, right? Like, so this is important. Whether there's something before the arrow or not is important. And you notice that no arrow that comes out of S2 writes anything. So S is more like a reading and moving the... yeah, so Ed, have a look at like the description of the stream from Saturday. You also have chapters if you want to jump straight to like minute 58 something where I start kind of writing what they're about. By the way, the very first exact task confirm on quit has been updated in version 2 of the code, which I hope you were still all working from in the first place. Okay, so I'm back here. What's going on? I mean, that's fine. I decided to go past the 20th line because I'm brave. Actually, the first 20 state, that was the header, right? So I've only got 19 states here. So I am in S5 because I have read the hash and moved back. And in S5, if I think I'm going to move back again until I see a, reason to move forward. I'll stop seeing ones. And let's take all of this. Actually, all of this. Paste it here, and I move back. I read nothing, and I write a 1. Because I mean, I read nothing, I write a 1, and I end up in S7, where I am going to keep looping on S7 until I stop seeing some 1s, and so you move back, you move the head back towards, you write as many 1s ultimately because you go back and forth as there are 0s that you read. As you wipe the 0s, you keep track of how many of them you've counted because you've written the 1s. And then, although I feel like I'm missing one because I think I messed up the beginning. And then once you've done all of that, because like now we've caught all 3 0, but like weirdly, I guess, is that meant to be in binary? That's very clever. Because 11 is 3 in binary, so who knows? They've wanted to pick a simple enough example, but like this is kind of confusing. So I am in S7. I am going to loop back, right? Kind of like I've written the new 1, and I'm moving all the way back until I find the hash, which was the start, because like you're writing the 1 in the area before the start, and that takes me back to S0. But in S0, if I find in S0, if I find nothing, I keep... Yeah, that's right. S0, as soon as you find nothing, you move to the right, which I happen here. And because then you're going to find that you've got nothing, 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 right? Because now we've counted all of the 0, and that's S8, that's your receiving state, and you end. I think the reason I misunderstood by the way, the regular expression is because of I don't know what the receiving state means. Just like it ends, right? Which is what's a bit weird that it would have like arrows coming out of it. But whatever, is that the stop state? I guess, whatever. This is the receiving state with the arrow, and like this an end point. So yeah, this successfully does what it says it does, right? Count the number of zeros between 2 symbols. Okay, and the rewrite sets to the right of a cell containing such a thing. The cell containing somewhere in the tape on the right, we end, and there's exactly 2 of them, so we don't encounter this. So that can be our bug. I'm gonna give that a pass. Frankly, the table has broken me. A universal Turing machine is like this one, but it's got infinite tape length and infinite, storage capacity for its state transitions. One reason why there are some problems that no real computer can solve and that the universal Turing machine could solve. Yeah, I remember there is some of these in there. Well, I mean, I guess like the universal Turing machine has got infinite memory, so there are. I guess now we got distributed computing and big data. It's very difficult to think that you could run out of storage space, especially if like every slot is a 1 or a 0, right? Because this is done in individual bits. But theoretically, the universal Turing machine has infinite memory, which no real computer has. Although I suppose the amount of memory that real computers have would be considered large enough to be practically infinite back when Alan Turing was coming up with this theory. I think I'm not, even the teacher, but I blame the board, right? They kind of like completely messed it up, and it's not my misreading of the question and being unable to do a trace correctly. Whoa, oh no, regular language, whatever. Okay, what? Oh, so yeah, okay, so the first one is yes. So that was the starting line, right? Okay, we move to the right and we end up in S2, yes. We move to the right and we end up in S1, yes. And then we go back to S2 moving to the right, yes. And then I've got S4, 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 and then S5 and S7, which are all kind of like movement related, more or less. S7, there's a 1 in here, yes, because we've written it to the right of it. Yeah, because in S5, we write that 1 and we say 7 is the one to move back. We move back, we go to S1, so I get that mark here. And then, yeah, and then there's no marks there, but you do need to get that right or like broadly right, so you hit that one last mark here. So it took forever. And so this is not good time management. And I'm going to say this to those of you that feel like it's not necessarily about being good, but like if it tends to kind of not be completely orthogonal to being good, like if you enjoy the problem solving, it is entirely possible out of a stupid sense of pride and not letting yourself be defeated by what's essentially the dumbest form of computer that like had never existed physically and was just sort of a thought experiment from Alan Turing, but this is important because it defines the total set of computable problems, and turns out there are more than what you'd think, although whether intelligence itself is whatever. Yeah. There are no zeros between two hash tables on a tape. Yeah, if it's already all blank, you're shafted. Or is there, no zeros? Yes, because you can't write the 0. You need at least one. A character other than 0, a 1 between the two hash tables on the tape. Only one character? I mean, come on, like that's implied when you're using the machine. To be honest, that wasn't given as one of the conditions, so you could have thought about this, right? I feel like that there are no zeros at all, because you should, unless you start with like a deliberate 0 in the cell to the left of, I'm doing it for your direction, to the left of whatever it is, to the left of the first starting hash that marks the boundary of the area we're trying to measure zeros in. Yes, right, if there are no zeros at all, if it's like all ones or blanks or whatever, because you'd never written the 0 as like the value you should find. But if there is a character other than 0, so really I would have hoped that all of this monarchy would allow us to count the ones correctly as well. But maybe I'm mistaken. Okay, a Turing machine can execute similar Turing machine. What? Faithfully execute what? Can compute any computable sequence. Wait, so it needs that's that's. I would have said that a computable sequence is defined by the one that can be computed by a Turing machine. That's what being Turing complete as a programming language is. And it's like, faithfully executed. What was the question? What am I looking at here? Yeah, an universal Turing machine here for 2 mark. Faithfully execute every single of the data precise simulated term would. What do I mean? Ah. Okay, so maybe I didn't know enough of the sort of more knowledge, with AO1 knowledge of the Turing. I've always thought that, yeah, infinite tape, whatever. No, but that's the thing. So the instructions are, yeah, the infinite Turing machine is, the universal Turing machine is like your von Neumann architecture of the Turing machine, in that it doesn't have a separate state transition diagram. It like reads this instruction from the tape. Surely that means you're going to need some memory, like whilst you move from one to the other, or you're going to go back and forth, but I don't want to. I'll be very honest, as I'm sure you know, you always have two teachers at A level, and although I taught all of the kind of skeleton code, and a lot of, you know, graph trees, abstract data types. I think, yeah, but I also taught a lot of paper too, because like the thing, and like annoyingly things like, not Baader-Meinhof, Bakker-Nose, normal, Bakker-Nose forms, context-free languages, and Turing machines and the like, which I think are kind of the part, it's the part of paper one. That's I think the part that's more exciting, that like how the storage devices and how do laser printers work, and yeah, I'm not saying this is more exciting than the FX and the law, because I think that's actually really, really important, but like teaching computer science has allowed me to reconnect with a much broader computer science than including its roots in mathematics than what I would have done as a software engineer. And so that was kind of a joy, and I was kind of keeping an eye on this, but I never really kind of taught it. So I'm not as hot about as this as I'm at with, like, you know, infix notation, like prefix, whatever, like type of infix, prefix, postfix notations, and tree traversal and graph traversal, the bits of the spec, even the bit, like the non-coding bits of the specification I would teach. So maybe I should mix it up. Anyway, I think that, so there's no section D at all. If I see some reactions in the chat, I can get started on section D for a bit, but like it's been like almost 2 hours, so I think you've got enough material on this. I will be, what's today? This is D-2. I will be doing one tomorrow. I'm also mindful of the fact that, yeah, if you were sitting music today, this is going to be interesting to see like what is the typical audience like in the channel as to what other A levels you're doing, because I'm glad of the turnout today, because clearly you weren't sitting music, but maybe tomorrow you will be sitting business. So anyway, tomorrow I will be streaming, but I will start a little bit later, and I don't know if I'm going to keep it for too long, because I want everyone to get an early night so you can be ready. I don't think I'm going to be doing something in the morning. But yeah, we will speak. I will speak at you again, and this time I will start the stream at the right time. Did I put the timing on the God damn it, I didn't put the time on the Turing machine. Maths and economics, which is not the same as business economics, right? Although there's some overlap. Yeah, maths, I know that was it at Excel that really messed up on a super hard question? Yeah. So, well, anyway, so I will be seeing you tomorrow after business paper 3, for those of you sitting business paper 3. Don't hesitate to send your questions. The signal is still, I think, like at the bottom. I might put it back. It's at the top of the chat as well, if I just can put it back again. You can find my email, by the way, in, if you know where to, oh, I think I've pasted a whole bunch of, I know, because I'm pasting a link to, sorry, the link to Signal is, I'm trying to paste in is kind of wrapped into the YouTube link to link the thing, so forget about it for a bit. No, hold on, I've got it here. Yeah, hold on. There we go. Send me some. I've not been checking Signal for all I know, to be fair. Oh, 14. Wow, no, okay, no, it's not. It's just the regular people I ignore. Fine, okay, sure. Send me your question in advance if you want. I will be rechapterizing the past streams and correctly creating chapters for this one, which is now all about section A. I need to rename it. And I will be making a short little video, maybe a short. I don't know if I can be bothered. But just to point people that are discovering the channel and like find that. I think there's more, if you that close to the wire, there's almost more value in some bits that are spread across like the past 3 streams of this weekend than they are in the properly made videos. The viewers might disagree because it's kind of a bit more rambly and a bit less focus in the streams, but like each, you know, an hour and a half stream has always got like 5-6 items. You know, there's a couple where I'm doing some section Bs. There's the last one, there's a trace for, it was fun, trace for a tree traversal, which was quite nice. This one we've done a whole bunch of section A. If you're interested about predictions and types of questions, that's the first one, I think, like Saturday, Friday, whatever. Yeah, anyway, there's like, I like the information is here. And it'd be helpful for me to kind of chapter everything so I can know which part to point you to. But I wish you all the best, and remember, you're not gonna actually get better by just watching this. You need to be coding for section D, and you need to be practicing on past paper for section A. So I think I stop the streaming here. If I stop it, because sometimes I click the button and it cuts it far too soon.